Orion parachutes perform. But in order to get only do we see those 11, but another 10 getting us there.
So 21 total?
21 total.
Okay.
So the first thing you're going to see is our tow chute. So that tow chute comes out and it'll be attached to the aircraft for a good 10 seconds before it pulls out our 2 extraction parachutes. Those 2 extraction parachutes are about 28 feet in diameter, and their job is to pull the test vehicle on the pallet out of the aircraft. As the pallet is getting extracted from the aircraft, it'll pitch down. The capsule will release from the pallet, and we'll deploy 2 programmer parachutes. Now, these 2 programmer parachutes will get us set up to the right test point to begin our free fall that Randy described. We'll free fall for about 12 seconds to gather up that speed to get to a high, what we call dynamic pressure, to really test the parachutes on the forward bay cover. That starts the real test. Now, our 3 forward bay cover parachutes will be mortared out of the cover, followed by 2 drogue parachutes, 3 pilots, and 3 mains. So I'll give you the play-by-play as everything's coming out.
Sounds great. And what specifically are you testing on this drop, and how does it help certify the parachutes to carry humans?
Excellent question. So this is the final qualification drop, and this is a full system. So we're testing all of our parachutes. As Randy described, we test various failure scenarios where sometimes we don't deploy an FVCP or we don't deploy a main. This will have all 11 parachutes, and we're looking for an orderly deployment of those parachutes, meaning the components come out when we expect them to come out. We'll also look at the chutes after we recover them. So the test doesn't end after touchdown. We'll recover the parachutes, inspect all 11, look for any damages that are unexpected. We do expect some damage landing out here in the desert. We got some prickly bushes, but we are looking for any flight damage that might be of concern.
All right. Now we're going to take a couple questions from folks watching on NASA TV. Again, if you'd like to submit your question, please use the hashtag AskNASA. All right, let's see what we've got here. Under normal conditions, what is the deployment altitude for each parachute type?
Excellent question. So Orion, it re-enters the atmosphere at about 17,500 miles an hour and uses the heat shield, basically the drag on the blunt body of the spacecraft, to slow down to about 350 miles per hour at about 25,000 feet. At about 25,000 feet, we begin the sequence of deploying the forward bay cover parachutes to release the cover, followed by the drogue parachutes immediately after. We'll ride those drogue parachutes down to about 6,000 feet above the Pacific Ocean, and at 6,000 feet, cut away those drogue parachutes and immediately deploy our pilot parachutes, which pull out our mains, which take us down to 0 feet. Okay.
And what materials are used for the chutes?
Excellent question. So we use a combination of materials, mostly Kevlar and nylon. So everybody's heard of Kevlar, kind of using bulletproof vests. It's very tenacious, very strong for a relatively lightweight. We use that Kevlar for our load-bearing members. We call them our radials, our suspension lines, our risers. And then the drag-producing members, we use materials like nylon, which are very lightweight, very thin. You can actually see through the broadcloth on our orange and white mains. And those produce the drag that gets transferred down to the spacecraft.
All right, and how much has technology for parachutes changed over the years?
Excellent question. It's changed quite a bit, a lot in the material properties. Apollo used steel risers, which are very heavy, very bulky, hard to pack into the spacecraft. We've been able to transition to Kevlar risers now that we have Kevlar available. So that saves weight. It makes the packing, the integration a lot easier. We also have a lot better computer simulation techniques to help us both here out on the drop zone and to simulate what's going to happen with the actual spacecraft so that we can get to the final design solution with fewer drop tests.
All right. And how heavy is the Orion crew capsule that the parachutes are bringing down?
Orion's about 21,000 pounds. So that's a lot of metal, a lot of systems in there, including our humans, and the humans are the most important part. Looks like we got about a minute until we have our extraction.
All right. Do you think we'll be able to spot the plane?
Yes, so we've got some folks helping us. They'll be coming in over here from the east, right about where the sun is, so just be careful not to look directly into it.
All right, let's see if we can get a shot on the plane. All right, I can actually hear one of the planes.
Yep, that's actually one of our support helicopters. So we have various aircraft at different altitudes. Video and imagery is very important for us on these tests. So we have aircraft staged at various altitudes to get the right sequence of video and photos. You can see we have one chase aircraft there. Okay, there's our tow chute. So our tow chute is out. It's held on, anchored to the aircraft right now. In a moment, the crew will release, and it will pull out our 2 extraction chutes. And there go our 2 extraction chutes about to pull out the pallet. There's the pallet with separation on the PTV right there. Now we have static line deployed 2 programmers. Now those 2 programmers will stabilize the vehicle and get us to the right altitude, attitude, and velocity for us to begin the test. The test will begin with severing those programmers for that 12-second free fall. Now the vehicle is unstable at these speeds. So we have software on board that will monitor the rates and the attitudes of the vehicle to make sure that we don't tumble forward. We don't want to tumble the vehicle. That would be bad for our drogues to be deployed at apex forward. So our software will monitor the, there's our free fall. So if you want, you can count to 12. Looks pretty stable. That's looking great. You will soon see the 2 drogues, or excuse me, 3 forward bay covers. There they go. They lift off the cover's separated, 2 border deployed drogues. You can see lots of debris in the air. Those are the lids, the bags, other equipment. So now we're riding these 2 drogues. They are reefed. That means that we have a line wrapped around the skirt of the parachute, constricting the diameter of the chutes to modulate our drag area, to reduce our loads, and to kind of help with an orderly inflation. So now we're going to ride these drogues down to as low as we possibly can. The actual Orion vehicle with our astronauts in it will descend to the ocean, which is at 0 feet mean sea level. Here at Yuma, we're at about 1,500 feet mean sea level. There's the 3 pilots, 3 mains. Now these will inflate through reefing stages similar to the drogues. It's more pronounced on these mains. So you can see a light bulb shape there in the 3 mains. This is looking really good so far. Now we're into the 2nd stage. They're a little bigger. And if you listen closely, you can hear those mains inflating. And there we go to the full open. Beautiful shot right there. 3 mains spread out. You can hear the crowd in the back cheering. We're not quite done yet. There's still a lot of stuff in the air. Eventually we'll see the cover come racing by and impact the desert floor. But here you can see the 3 mains bouncing in and out. That's completely expected. You can see there's holes in the sides of the parachutes. We put those there. They're supposed to be there. We call that geometric porosity. That does reduce the drag of the parachutes, but it does increase the stability. So the increased stability makes those flyouts smaller than they normally would be, which means that on average, our drag is higher. So one of these 3 main parachutes was actually what we call environmentally tested. So we put one of these parachutes through the entire sequence that a flight parachute would see. This includes what we call creep testing, thermal cycling between high and low temperatures, vibration testing, and rapid depressurization testing. We did all that throughout this calendar year and then integrated it directly onto this vehicle to validate the design to ensure that it can go through those environments without having any issues. So we've seen the 11 Orion parachutes, and there's also the handful of test support parachutes. There is one parachute descending the pallet to the ground. Now this is a special parachute. It is very similar to our Orion mains, but the lower sails I'm not sure if the camera's on it, but it's got a lighter weight broadcloth. Oh, there we go, we've got touchdown. So Orion looks like the test vehicle is upright, so that's great. That makes recovery easy. A lot of times it will flip over. It's not designed to land here in the desert, so when it hits the hard ground versus the water, it kind of rolls around a little bit, but that's not a big deal. You can see those orange chutes deflating and falling to the ground. The ground winds are very important during this testing in terms of safety for the personnel that go out to recover the chutes. You can see one of those main parachutes is still a little bit inflated, but that will droop down as the mouth of it kind of closes up. So the safety of the crew and safety of the personnel is very important in the recovery. If those parachutes are inflated, they generate tens of thousands of pounds of force, and that could be very dangerous to anybody going out to recover them.
All right, and so what's next?
So next is the recovery process. So this was the hard part. Next is also the hard part, I guess. So we'll drive out there and we'll go recover each of these parachutes, all the other equipment, bag them up and take them to our shakeout tower. At the shakeout tower, we'll string them up, shake out all the sticks and scorpions, and look at any damage that we may have incurred.
Okay, and so Jared, all right, I can imagine that, no 2 days the weather conditions are exactly alike. So how do you design a parachute system for all the conditions that we could possibly experience when coming home?
Excellent question. So it's not so much the weather that Orion has to worry about, but it's the entry conditions. So we have to design the parachutes to perform well in everything from an abort scenario to a nominal entry. So a nominal entry is up at 25,000 feet, 350 miles an hour, whereas an abort could be from the pad, and we need those parachutes to work very quickly to get the crew to a safe speed before we hit the water. So it's a lot of testing here, testing all those various scenarios to ensure that we have the data to inform our computer models, which will tell us that the parachutes are safe.
Great. Well, congratulations for completing the test series to qualify Orion's parachutes to carry humans.
Thank you very much.
All right. Well, thanks, Jared, for talking us through the questions and answering our questions and talking us through the test.
You're welcome.
And thanks to everyone that joined us on NASA television. This test completes the parachute testing to get ready for crewed missions. And together, Orion and the Space Launch System rocket will be the backbone capabilities that will carry humans to the moon and extend human presence into the solar system farther than ever before. If you'd like to follow along with the progress we're making on the Orion spacecraft, please visit nasa.gov/Orion. They're having some technical issues, so I haven't confirmed that we're clear yet.
Gotcha.
If you wouldn't mind just hanging out for a minute or two. I'm sorry, I didn't give you the update.
It's cool.